So hello everyone, welcome to this new video. So in our previous video we had started with one concept of module 5, right? The name of the module 5 is IIR filter design, that is infinite impulse response filter design, and we have told you in order to solve those kind of problems we have two different kinds of methods. One is IIM method, that is impulse invariance method, and in that method we have seen that formula of impulse invariance method, how it varies from S plane to Z plane and what are the changes required to make, and we have solved two important problems in that session. Okay, so please those who have not seen that previous video, please do see that previous video, because that concept is very easy and you will be understanding it very easily. Okay, two problems you have solved, go through that and then come and watch this video and like this video. Okay, so don't skip any part of the video, watch till the end, guys. Okay, so this is the first question of this session, that is using IIM method to design a digital filter from an analog prototype that has a system functions. We have three sub questions in this here. Okay, one by one we are going to solve. Okay, very easy. First question is h of s is equal to s plus a divided by s plus a the whole square plus b square. Second is b by s plus a the whole square plus b square. C is s divided by s plus a the whole square plus b square. If you observe in these three sub questions also the denominators are same. Okay, so let us see one by one what are the results which we obtain. Okay, first sub question, let us solve it now. First, in order to bring it to partial fraction form, we should be splitting the denominator, right? That is s plus a divided by, this is of the form a plus b the whole square, that is s square plus 2as plus a square plus b square, right? Because this I have written it as a square plus 2ab plus b square. Okay, now using this denominator we should be splitting this into two roots. We should be having two different roots, right? So that we could be writing in the partial fraction form. But here we don't have any number here. They have given the variables a and b. So what we can do is we cannot put the equation in the calculator. We should be solving this manually by using the quadratic formula. S is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. This formula you are familiar with, because this formula is very familiar to you because you have solved many problems in our previous semesters, this formula. Okay, so in this, what are the values of a, b and c? The coefficient of s square, the value of a is 1, then the coefficient of s here, the value of b, that is 2a, and c is the remaining constant, that is here in this case it is a square plus b square. So these are the substitutions which we will be making in this formula, and let us see what are the roots we obtain. So minus b, so that is minus 2a plus or minus square root of b square, that is 2a the whole square, that is equal to 4a square minus 4 into 1 into c. What is c? A square plus b square divided by 2, right? So what we get, s is equal to minus 2a plus or minus square root of 4a square minus 4 into a square plus b square, so minus 4a square minus 4b square, right, divided by 2. So 4a square minus 4a square goes, so we are left with minus 2a plus or minus square root of minus 4b square whole divided by 2. So minus sign is there, so we would be getting one complex term, right? Since you know the square root of minus 1 is I, so minus 2a plus or minus square root of minus 1 is I, so j, then 4b the whole square, square root of 4 is 2 and b square is b, so 2b whole divided by 2. So what I am doing is I am taking 2 common here, so 2 into minus a plus or minus jb divided by 2, so 2 gets cancelled. So our two roots are minus a plus jb and minus a minus jb, right? So these are the two roots here which you have got. So now these we should be substituting here, that is now h of s would be equal to s plus a divided by s minus of first root, that is minus a plus jb, then the second root is s minus of minus a minus jb. Okay, so like this we have written our h of s now. Now for this we should be applying the partial fractions and we should be solving the rest of the problem. Okay, so now let's further proceed. So after thinking the partial fraction, would be left with a divided by this term, that is s minus of minus a plus jb, plus b divided by s minus of minus a minus jb. So in order to cancel the two terms, we should be cross multiplying so that we would be having the common denominator. So what we would be getting now, here in this side we have s plus a, don't forget to write that. So s plus a would be equal to cross multiply a into s minus of minus a plus jb plus b into, so here it is minus jb, okay, s minus of minus a plus jb. So this is the equation which we have got. In this now, one by one you should be finding the values of a and b, right? So how to find the value of a? You should be making the b term completely equal to 0, right? Before that we can solve this. We can further simplify and write it as a into, multiply minus sign, so it would be s plus a plus gb, and here we have b into s plus a minus jb. Now for this, let us find the value of a and b one by one. First we should find the value of a. For that we should be writing the reciprocal signs of here, that is in order to make this whole term equal to 0. Here we should be writing, we have plus a, so minus a minus jb, so plus jb. So first put the value of s is equal to minus a plus jb, okay, that is, here you substitute it, minus a plus jb plus a, here minus a plus a goes, so here also minus a plus jb plus a plus jb plus b into, so minus a plus jb plus a minus jb. So here minus a plus jb minus jb goes, this whole term would be equal to 0. Here also minus a plus a goes, so here we are left with only jb is equal to, jb plus jb is 2jb, a into 2jb. So here also jb goes, so we are left with 1 is equal to 2a. So our value of a would be equal to 1 by 2. Right? Similarly, find the value of b. Now to find the value of b, we should be making the value of s as minus a minus jb, right? So put s is equal to minus a minus jb. So our equation would be minus a minus jb plus a is equal to, so the a term would be completely 0. We would be left with only b term, that is minus a minus jb plus a minus jb, right? So minus a plus a goes here, in both time we are left with minus jb here. So here minus jb is minus 2jb, so b into minus 2jb, so jb goes, we are left with minus 1 is equal to minus 2b, or 1 is equal to 2b. So b would be equal to 1 by 2. So both the values a and b are 1 by 2. So now we should be substituting that in our main equation of h of s, that is 1 by 2 divided by s minus of minus a plus jb plus 1 by 2 divided by s minus of minus a minus jb. Right? So now this is of the in order to represent into h of z plane, we should be applying the IIM method now. So now what we would be having our term 1 by 2 divided by 1 minus e to the power whatever the root is present here, s minus p, this is pk root, right? That you should be writing as it is, that is minus a plus jb, okay, and the value of t they have given it as 1, so I am not writing it. Here also the same thing, 1 minus e to the power whatever root is there, minus a minus jb z inverse, okay. So now we have substituted this. Now we can further solve it by just cross multiplying. Now cross multiply and see what how further we can solve this. So my 1 by 2 we should be multiplying with this whole term, so what we would be getting 1 by 2 into this term now, that is minus 1 by 2 e to the power minus a e to the power minus jb. I'm splitting the powers here and I'm writing with along with the base, okay, into z inverse. So these two are multiplied. Now these two we should be multiplying. 1 by 2 into 1, that is again plus 1 by 2. 1 by 2 into minus of this term, so minus 1 by 2 e to the power minus a e to the power plus jb again into z inverse. So numerator part is done, divided by these two should be multiplied, right? So 1 into this whole term, so this whole term would be repeating 1 minus e power minus a e power minus jb z inverse. Then these two terms you should be multiplying, minus e power minus a plus jb z inverse into 1. So you will be getting this term again as it is, that is minus e power minus a e power plus jb z inverse. So finally these two terms should be multiplied. Minus minus is plus, so we have e power minus a e power jb into e power minus a e power minus jb, and z inverse into z inverse is z to the power minus 2. So here we have one is plus jb and one is minus jb, that would be equal to e power 0, that is 1, okay. So now again we can see that in the numerator we have 1 by 2 plus 1 by 2, half plus half is equal to 1, right? So this write it as it is. So now 1, then rest all the terms if you see here, minus 1 by 2 e to the power minus a z inverse is common in these two terms, right? So that I am taking outside here, minus 1 by 2 e power minus a z inverse into the remaining terms, that is here we have, so let us write this first, e power jb plus e power minus jb, the whole divided by, again here 1 minus, here in these two terms again minus e power minus a z inverse is common, I'm taking that outside, into the left out terms are e power jb plus e power minus jb plus e power minus a is e power minus 2a z to the power minus 2, right? So if you observe here carefully, numerator as well as denominator, we have e power jb plus e power minus jb. So that is we can write this as of this form, that is we know that what is cos theta equal to e power j theta plus e power minus j theta divided by 2, right? So we can substitute this in as cos theta. In place of theta we should be substituting as a b, right? But we have 2 in the denominator here, and we don't here also we are having 2 here, okay. But in the numerator we can substitute it as cos b, but in the denominator we are not having divide by 2 here. So what we should be doing, we should be multiplying and dividing by 2, so that this would be equal to cos b, right? So here I am multiplying and dividing by 2 here. So now we would be getting our final h of z is equal to 1 minus e power minus a z inverse into cos b divided by 1 minus 2 e power minus a z inverse into cos b plus e power minus 2a z power minus 2. Okay, so this is our value of h of z for our first sub question. Okay, like this you should be solving. So those who did not understand, please go through the problem once again. Very important problem. So now let us solve the second sub question. So this is the second sub question, that is b divided by s plus a the whole square plus b square. Again you can see that the denominator is consisting of the same term, that is s plus a the whole square plus b square. So we have already found out the roots, that is s is equal to minus a plus or minus jb, right? That only we are applying for this also. So directly what we can write is h of s is equal to b divided by s minus of minus a plus jb, s minus of minus a minus jb, directly, because the denominators are same, right? So now for this apply the partial fraction rule, that is a divided by s minus of minus a plus jb plus b divided by s minus of minus a minus jb. So here we have b, right? So b would be equal to, so cross multiply, that is a into s minus of minus a minus jb plus b into s minus of minus a plus jb, right? Now, so now for this, one by one you should be substituting the value of s, so that we would be getting the value of a and b. So here first let's find the value of a. For that let us first further simplify this. S plus a plus jb b into s plus a minus jb. So here first let's find the value of a, so that b term would be equal to 0. So we should be substituting s as minus a plus jb. So b would be equal to a into minus a plus jb plus a plus jb. So we know that b term would be equal to 0, so I am not writing that again. So minus a plus a goes, so b would be equal to a into jb plus jb is 2jb. So b goes, we are left with 1 is equal to a into 2j. So our value of a would be equal to 1 by 2j. Okay, so similarly put s is equal to, in order to cancel a term, we should be substituting the value of s as minus a minus jb. Okay, so b is equal to b into minus a minus jb plus a minus jb. So b would be equal to b into minus a plus a goes, we are left with minus jb minus 2jb. So b goes again, we are left with 1 is equal to minus b 2j. So that is equal to b is equal to minus 1 by 2j. So we have got two values of a and b, 1 by 2j and minus 1 by 2j. Both are complex. So now let us substitute back in our main equation. H of s is equal to plus 1 by 2j a, that is equal to s minus of minus a plus jb minus 1 by 2j, because the value of b is minus 1 by 2j, then that is equal to s minus of minus a minus j, right? Now write it in the z domain, z plane. So that would be equal to 1 by 2j divided by 1 minus e to the power whatever power, that is minus a plus jb, and the value of t is 1, so I am not writing it. 1 minus e to the power minus a minus jb z inverse. So now cross multiply and try to solve it further. So 1 by 2j into this whole term, so that is equal to 1 by 2j minus of 1 by 2j e power minus a e power minus jb z inverse. So minus 1 by 2j into 1, again minus 1 by 2j minus of 1 by 2j. So now this would be plus, because minus 1 by 2j and here we have minus sign, so that would be plus now. E power minus a e power plus jb z inverse, the whole divided by these two terms we should be multiplying. So 1 into 1 is 1, 1 into this whole term, that is minus e power minus a, then this term into 1 minus e power minus a e power jb z inverse, then this term into this term minus minus plus e power minus a is minus 2a plus jb minus jb, that would be equal to e power 0, that is 1. Z inverse is z to the power minus 2. Okay, now here let us further solve this. So here if you see here 1 by 2j and minus 1 by 2j, we can cancel them. Okay, now what we can do is we can take 1 by 2j e power minus a z inverse common, and the rest of the terms let us write it, that is e power jb minus e power minus jb. Okay, in the denominator also the same thing, 1 minus e power minus a z inverse, take it common, e power jb plus e power minus jb plus e power minus 2a z power minus 2. Okay, further solve it. So now here this is of the form sin theta. If you observe here, e power j theta minus e power minus j theta divided by 2j. So here we have 2j and in place of theta we have b. So what we can do is simply e power minus a e power z inverse into sin b divided by 1 minus, again we have this is of the form cos theta, right, cos b. So we should multiply and divide by 2. So 2 e power minus a z inverse cos b plus e power minus 2a z power minus 2. Okay. So this is the final answer of h of z which you have got for the second sub question. So similarly let us solve for third sub question. So here this one we should be the third sub question is a mixture of whatever the two sub questions we have solved. We should be using that. How? Because the first step only what we should be doing is h of s, we should be writing it as s plus a minus a, okay, divided by s plus a the whole square plus b square. Okay, now what to do is split it and write it as s plus a divided by s plus a the whole square plus b square minus a divided by s plus a the whole square plus b square. So for this we know that first sub question we had this question and whatever answer we got, right, that we should be substituting. But here we have a, but actually we have solved for b divided by s plus a the whole square plus b square. So for that what I am doing is I am multiplying and dividing by b in this side. Okay, so let us see what we would be getting further. S plus a divided by s plus a the whole square plus b square. So if you multiply and divide it by b, we would be left with the 1 by b, sorry, a by b, b divided by s plus a the whole square plus b square. Right, now we got here b. So now we should be substituting these two, whatever we have solved, sub question 1 and 2, and then write it in the h of z plane. Okay, no need to solve it, we can directly substitute and write it. Okay, so what is s plus a divided by s plus a the whole square plus b square? That is equal to 1 minus e power minus a z inverse cos b, okay, divided by 1 minus 2 e power minus a z inverse cos b e power minus 2a z power minus 2, okay, minus a by b into, again this term whatever we have solved, the answer we have got here, e power minus a z inverse sin b divided by the same denominator again, 1 minus 2 e power minus a z inverse cos b plus e power minus 2a z power minus 2. Okay, now we can see that the denominators are same, and a by b we should be multiplying in the numerator here, that is h of z 1 minus e power minus a z inverse cos b minus a by b multiplied to this whole term, so we will be getting minus a by b e power minus a z inverse sin b with a common denominator of 1 minus 2 e power minus a z inverse cos b plus e power minus 2a z power minus 2. So in the numerator, if you observe carefully, we can take 1 minus minus e power minus a z inverse common here. So what are the left out terms? Cos b, since we have taken minus e power minus a z inverse common, so we are left with plus a by b sin b, right, the whole divided by 1 minus 2 e power minus a z inverse cos b plus e power minus 2a z power minus 2. So this is our final value of h of z which you have got. Okay, so like this, in this way we should be solving these kind of problems. So that's all for this session, guys. This video was a bit long, but this question which I've solved, right, that is very important. Okay, these three sub questions, any one of them would be definitely asked, so please be prepared for this. Like, share, subscribe to our channel, guys. We'll see you in the next session. Thank you.